So GCC, we are going to go through our Chapter 1 slides. Chapter 1 is over matter for the Chem 130 course. So we're talking about chemistry. It is the central science. It is the study of the composition, structure, properties, and physical and chemical changes of matter. So we're going to study basically atoms, how atoms bond, what they're made up of, protons, neutrons, electrons, reactions of chemicals. We're going to study a lot about the periodic table and periodic trends. We're going to talk about acids, bases, electrolytes. We're going to talk about the mole and stoichiometry. We're going to talk about intermolecular forces, solutions, and gases in this course. There are several branches of chemistry. Believe it or not, your chemistry professor does not know everything there's to know about chemistry. It's just like in history. History professors specialize in a certain time period or maybe a certain country, like Czechoslovakia. Maybe they know about Czechoslovakian history, but they don't know anything about Poland. Chemistry is the same way. We specialize in certain areas of chemistry, and we're experts in that area. There's no way you could know all of chemistry. So some of the branches of chemistry are inorganic, organic, biochemistry, physical chemistry, chemical education, the study of teaching of chemistry, environmental chemistry, which is very important these days, analytical chemistry, and then also nuclear chemistry, which is very interesting. Your professor probably specialized in just one of these areas. Why should we even study chemistry? Why is this a required course for you? How does chemistry impact your daily life? Well, one of the most important ways, batteries. Where would we be without our gadgets that run on batteries? Oh my goodness, we love our battery-operated gadgets. How about electricity? Imagine if you lived before electricity. Oh my goodness, what a difficult lifestyle that was compared to what we have now. Water, having clean water, that process is chemical. So it's very important that we have clean drinking water. All of our energy needs for our cars, for the light rail, for our houses, all of the energy needs are met through chemistry. Nuclear bombs, that's nuclear chemistry. Dynamite for construction, fire is a chemical reaction. And then all your personal consumer products, deodorant, shampoo, and makeup, those are all chemicals made by chemists. Drugs and medicine, the pharmaceutical industry, whatever you think about it, employs a lot of chemists. The recycling process, which is so important to us now, involves all sorts of chemicals and chemical processes. Plastics, we make a lot of things out of plastics, which are actually bad for our environment, but that's a branch of chemistry in itself. Alarm clocks, our cell phones, everything's made of chemicals, so it really impacts our life all the time. Alcohol, the study of how to ferment grapes to make our wine, is fascinating chemistry. Ink, the process of finding a good ink to dry on paper quickly and not smearing, that's a lot of chemists working on ink. And those are just the first things that popped into my mind. It goes on and on and on. So the first real important thing in this chapter is actually the scientific method. So there are 6 steps in the scientific method, the way we approach it. Number 1 is you make some sort of observation of a natural phenomenon, like maybe you put your soda in the freezer, you forgot about it, and then you opened up your freezer and it exploded. So you noticed your soda exploded. So you're curious about this and you want to know why. So you formulate a hypothesis. So maybe you think that the water in the soda expanded upon freezing. So maybe ice expands when it freezes. And then you're going to research your hypothesis. You're going to look at scientific sources, not just any old blog, and see what you come up with when ice freezes. Step 4, you're going to perform experiments, lots of them. You're going to try maybe some more soda, different kinds of soda, some water, put those all in the freezer. You can measure the volume of them before and after and see if the volume increases. Step 5, you can analyze your hypothesis, repeat experiments as necessary. It's really important that you do lots of experiments, not just one, lots of experiments. And then finally, we can draw a conclusion. Other scientists should be able to repeat your experiment and get the same results. If other people can't duplicate your work, then it's not really useful, is it? So that is our scientific method. Make sure you know the steps of the scientific method. This is really for lab, good observations. So for those of you in lab, I just want to make sure you know that a good observation includes the color, and if it looks like water, that's not clear. It's colorless. So So the color is colorless for water. If it's a liquid, the second thing is clarity. So that's when we use the word clear. So clear just means you can see through it versus cloudy, you can't see through it. Like an orange crush is orange and clear, whereas orange juice is orange and cloudy. And then think about beer. American beer is usually yellow and clear because you can see your fingers through your glass of beer. And then like a German dark beer, maybe that's dark brown and cloudy. You can't see through it. And then finally, the last thing in your observation is state of matter, solid, liquid, or gas. So orange crush would be orange, clear, liquid. Dark German beer would be brown, cloudy, liquid. An emerald would be a green solid, and so forth. So that's how you make good observations in lab. So matter. Matter is the study of anything that has mass, and all matter is made up of atoms, like that picture shows you there. A molecule made up of atoms. That's just a model. There are 3 states of matter. I'm sure you've already heard this before. There are solids and liquids and gases. In the solid, the atoms are packed very tightly together. They are touching, so they're very close. It's in a pattern, and the atoms move. They vibrate in place. So the idea that the atoms are still in a solid is incorrect. So the atoms do vibrate in place. If it's a cold solid, they vibrate a little bit, but if it's a hot solid, they vibrate a lot. Liquids. The atoms are also close together and touching, but they are free to flow and roll around each other. So atoms are also close together, but they are free to flow. In the gas, the atoms are far apart with lots of empty space in between them. They constantly move in straight lines until they hit something, and then they bounce off and go in a different direction. But atoms are very, very far apart in a gas. There's lots of empty space in between them. So you can see from those pictures what I've been describing. Properties of solids. Solids have a fixed shape and a fixed volume. So solids, we know their shape. We know if something's square, circular, round, and we can measure the volume of something. We know that it's 15 milliliters, for example. Solid atoms, as I already mentioned, vibrate in place in a pattern. Solids can be crystalline, meaning you can see through them, like diamonds, emeralds, and rubies, or they can be non-crystalline, where you can't see through them, which is most solids. Solids are not compressible. The atoms are already so close together, you can't smush them any closer. So solids are not compressible. Most solids have a slightly higher density than their liquid state, meaning their ice cubes sink. So most liquids, you freeze it, the ice cubes sink. So solids sink in their liquid. Water is actually weird. Water ice cubes float. This is not normal. It is not a typical liquid. And we'll talk later in the course about why this is so wonderful for us. But water is weird. It is not a standard liquid. Most ice cubes sink. However, water ice cubes do float. Also, solids don't mix by diffusion or osmosis. You can't take 2 solids and just rub them together and have a reaction. That doesn't work. What about properties of liquids? Liquids take the shape of their container. So this liquid is now in the shape of my container, my Starbucks cup. And it has a volume. So this is maybe 800 milliliters. Different liquids flow at different rates. That's called viscosity. We'll discuss that in this course. Liquids are not compressible either. Again, the liquids are touching and they're close, rolling around to each other, so you can't smush them any tighter. Not compressible. Liquids have a much higher density than gases because, again, the particles are close together, just like solids. Solids and liquids are much, much denser than gases. Soluble liquids will mix uniformly together. If they're not able to mix, they make layers like oil and water. Finally, properties of gases. Gases do not have their own shape. They take the shape of a container. When I exhale, my gas just spreads out and fills up the room. The gas in this room is taking the shape of the room. My exhale doesn't have its own shape. I can't say, oh, it's round or square. That doesn't make any sense. Gases do not have their own shape. Gases can expand and be compressed because the atoms are so far apart, I can smush them closer together. So gases can compress. This means their volume can decrease and increase depending on the empty space in between them. So gases do not have a set volume. Gases have very low densities compared to liquids and solids. Air is about 0.001-ish grams per milliliters, so very small number. Gases mix completely with other gases, so if you put a lot of gases together, they will mix uniformly. Okay, they will not make layers. So air is a mixture of gases. What's the main component of air? What's the main gas in air? Oxygen? No, it's not oxygen. It's actually nitrogen. Nitrogen is about 78% of air. Oxygen's only 21% of air. And then you have 1% left for carbon dioxide, carbon monoxide, the noble gases, and other gases. Gases exert pressure. That's defined as the gas molecules hitting the sides of their container. And we're going to have a whole chapter on gases and pressure. So let's answer some questions. Look at this grid. We have solid, liquid, gas across the top. And then the question is, has fixed shape, has fixed volume? So does a solid have its own fixed shape? Yes or no? Solid. If you said yes, you're correct, it does. Let's see. Does a liquid have its own fixed shape? Whoops, wrong question. Does a solid have fixed volume? And the answer is already showing yes, it does. Okay, what about a liquid? Does a liquid have its own shape? No, liquids don't have their own shape. They take the shape of their container. Liquids take the shape of their container. Do liquids have a fixed volume? Yes, they do. The liquid in my cup's about 800 milliliters. So it does have a volume. What about a gas? Does a gas have a shape? No, it takes the shape of its container, like a balloon or the room. Does a gas have its measured volume? Does it have a fixed volume? No. Gases, again, can expand and compress, so they really don't have a fixed volume. So we can tell the three states of matter apart just by these two questions. And we're going to call it good for right now. I'm going to continue chapter 1 in a different video to give you a little break. Thanks for joining me.